Okay, for the next page, in polar coordinates, which of the following are correct representations for the point -3, -pi/3? So I'm just going to draw a quick graph of where this point is, because then I think it'll be pretty easy to see what other coordinates would match up. Let's get 3 rings going, and -pi/3 is right here. But we want to go backwards 3. So our point will actually be right there. Okay, so looking at our other choices, it looks like A is a correct answer, because if we start at 0 and we go around, that would be -4pi/3. So it looks like A is good. 3, 2pi/3 looks like it's a good answer because this angle is 2pi/3. We went forwards 3. 8pi/6. If we subtract 2pi from that, if we reduce, actually, I'm sorry, that would be the same as 4pi/3. And 4pi/3 is down here, so that does not look like it is the correct answer. -8pi/3, let's add 2pi to that. So let's add 6pi/3, and we'll get -2pi/3. So -2pi/3 would be here. So that does not look like the correct answer. So it looks like A and B are correct answers for 4. Moving on down to number 5. Convert from polar to rectangular coordinates. So we need to use 2 equations to help us convert, and that is x equals r cosine theta and y equals r sine theta. So for x, we have 8 times the cosine of 7pi/6 and 8 times the sine of 7pi/6. And I'm just going to draw that triangle out. So it's down here. We know it's a 30-degree angle, so we have a -1, -√3, and 2. So the cosine would be -√3/2. And the sine would be -1/2. So after simplifying, it looks like we have the coordinate -4√3 and -4. So it looks like the answer is A. Now we want to convert from rectangular coordinates to polar. So to do that, we need these 2 equations. Tan theta equals y/x, and x squared plus r squared, or y squared, equals r squared. So let's find r first. So we want to do 5√2 squared plus 5√2 squared. I'm sorry, -5√2 squared equals r squared. So let's see, that would be 25 times 2, so 50 plus 50 equals r squared. So r is going to equal 10. All right, next thing we need to do is determine the angle. So we know that tan theta equals -5√2 over 5√2, which is -1. And remember, the coordinate that this point is in is, or I'm sorry, the quadrant that this coordinate is in is important. So we know that this would have to be in quadrant 4, since the x is positive and the y is negative. So we are dealing with a 45-degree angle, and it would have to be 7pi/4. So our coordinate is 10, 7pi/4. All right, moving on down to number 7. Change from a polar equation to a rectangular equation. So we definitely want to remember about the two formulas. X equals r cosine theta, or x over r equals cosine theta, and y equals r sine theta, or y over r equals sine theta. Okay, so let's plug in y over r for sine squared theta, but we'll remember to square it. And we'll plug in x over r for the cosine theta. So let's see, we have ry squared over r squared equals 3x over r. So it looks like I can cancel this r with one of these r's. So I have y squared over r equals 3x over r. Let's erase this equal to sign. There we go. And now if I just multiply both sides by r, it gets rid of it. So we just have y squared equals 3x. And if I move that 3x to the other side, we get y squared minus 3x equals 0. So we are dealing with choice B. Moving on down to number 8, we are converting the other way. We're going from rectangular to polar. So we definitely want to remember the two equations from above, and we want to remember that x squared plus y squared equals r squared. So we can turn x squared plus y squared into an r squared. And we can turn the x into r cosine theta. And we can turn the y into r sine theta. So for polar equations, we always kind of want to end up with an r equals. So let's move the 2r cosine theta and the 5r sine theta to the other side. So we end up with, oh, actually, in our choices, it looks like we didn't move anybody. So we have either C or D, but notice that there is an R in everybody. So we can divide everybody by R. So our final answer is R plus 2 cosine theta plus 5 sine theta equals 0. So we have choice D. Okay, for number 9, we want to find any zeros of r, and r equals 8 plus 16 sine theta. So first thing we need to do is set this equal to 0. And we'll subtract 8 from both sides and divide by 16. So negative 1/2 equals the sine of theta. So now we need to figure out, where does the sine of theta equal negative 1/2? What thetas give us that? So if we remember about all students take calculus, we know we have two triangles in the third and fourth coordinates, or quadrants. And we know we have a -1 and a 2. So we're dealing with some 30-degree angles here. And we would have 7 pi over 6 and 11 pi over 6. So our answer would be B. Moving on down to number 10, find the equation for the graph below. So this is where you would want to use your graphing aid to help you. So if we're looking at our graph, it looks like we are dealing with a limestone. And it looks like we have a dimpled limazon. A cardioid would come all the way into the 0. So for a dimpled limazon, A over B must be in between 1 and 2. So we can definitely cross off choice B. And let's see, A and B must be in between 1 and 2. Oh, we can definitely cross off choice E. So 4 over 3. All right, so it looks like our choices could definitely be either C or D. Since most of this limazon is in the positive quadrant, we know that we are dealing with choice D. If we had 4 minus 3 cosine theta, our limazon would be reflected over the y-axis. So that is the way that you can kind of narrow it down. All right, let's move on to number 11. Classify each of the following as a cardioid, a limazon with an inner loop, a dimpled limazon, or a rose curve. And we want to state the number of petals for a rose curve. So if we look at A, we know that this is definitely a rose curve because of the 3 theta. And if you look at your sheet, if we have n number of petals and n is odd, we just have that number of petals. So this guy's going to have 3 petals. If there was a 2 by the theta, we would have 4 petals because you need to double it. Next one is r minus 2 cosine theta. So if we put a over b, we end up with 1/2. And 1/2 is less than 1, so we are dealing with a limazon with an inner loop. Part C, we have 5 plus 3 cosine theta. So if we put 5 over 3, 5 over 3 is in between 1 and 2. So we are dealing with a dimpled limazon. And then finally, r equals 2 times 1 plus sine theta. If we distribute the 2, we get 2 plus 2 sine theta. And then if we put a over b, we get 2 over 2, which equals 1. So part D must be a cardioid. Again, the sheet will be given to you on the test, so you will be able to use it for all of these problems.